Thank you, everyone, and welcome to College Algebra. Today we will be discussing section 1.5, which is quadratic equations. And so let's get to it. Let me share my screen, and we will begin. All right. So section 1.5. We use study section 1.5, which is quadratic equations. All right, so the standard form of a quadratic equation, also called the polynomial of the second degree, is giving us ax squared plus bx plus c equals to 0, where the a cannot be 0. If the a is equal to 0, then it's no longer a quadratic equation. It's a linear equation. So the x squared term, the coefficient of the x squared term cannot be 0. All right, so let's move on to something that we call the zero product principle. The zero product principle. And what the zero product principle states is that if there are two, if the product of two algebraic expressions is 0, let me write it down. If the product of two algebraic expressions is 0, then at least one of them is 0. At least one of the factors. Then at least one of the factors is 0. So, for example, if A times B are two algebraic expressions, then either A is equal to 0 or B equal to 0. So this is what the algebraic expression states, and it will be helpful to us as we begin solving equations by factoring. Knowing the zero product rule will be helpful in us being able to find the x values once we do the factoring, as we shall see in the first example. So example 1. First of all, let's look at solving quadratic equations by factoring. Then we'll use an example to explain this one. So solving quadratic equations by factoring. All right, so let's use an example to explain. So example 1. We have to solve this equation by factoring 2x squared plus x minus 1. We have to solve this equation by factoring. All right, so to solve this equation by factoring, the first thing that we do is to identify what is our A, what is our B, and what is our C. All right, so if we compare this to the standard form, A, um, A is equal to um, A is equal to 2, A is equal to 2, B is equal to 1, and C is equal to -1. All right, so the next thing that we do is to find the well, the next thing we want to factorize this. So the next thing that we do is to find a way to express B in terms of the product of A and C. So you would realize that 2x squared plus x is the same as 2x minus x minus 1 is equal to 0. So x is the same thing as 2x minus x. So if we rewrite this equation as this form, then we can factorize. So we have 2x squared plus 2x minus x minus 1 is equal to 0. So we can factorize these two terms, and also these two terms. We can factorize a common, we can get a common factor out of them. So if we look at the first parenthesis, 2x is common to 2x and 2x squared, right? If we multiply 2x by x, we get 2x squared. So we can factorize 2x out, and we have a remainder of x here, and we have a remainder of 1 here. And for the second parenthesis, we can factorize -1 out. So -1, we have x here, and if we factor -1 out of, if we factor -1 out of -1, we have +1 here. So this equal to 0. So once we have this form, we can see that we have common terms, x plus 1, x plus 1. So we can factor x plus 1 out also. So x plus 1 and times the remainder we have here now is 2x. And the remainder we have here is -1 equal to 0. And at this point, we can use the zero product principle, which states that if the product of two algebraic expressions is 0, so then at least one of them is equal to 0. So by the zero product principle, we can say that x plus 1 is equal to 0. If x plus 1 is equal to 0, if we subtract 1 on both sides, we have x is equal to -1. And if we, for the second factor, 2x minus 1 is equal to 0. If we add 1 on both sides, we have 2x is equal to 1. And if we divide 2 on both sides, we end up with x is equal to we end up with x is equal to 1/2. Let me check again whether I made a mistake with any of the negative signs. Um, so, um, all right, so it looks like the negative signs are fine. We have um, x is equal to 1/2, and x is equal to -1 as our answer. And that we can check whether our answer is correct or wrong by substituting the values of x that we have into the equation to see whether we will get the same thing on the right hand side and the same thing on the left hand side. All right, so the first example, 2x minus 1 is equal to 0. So let's check whether our solution is correct. So let's move on to the next page. All right, so we have 2x squared plus x minus 1 is equal to 0. So if x is equal to negative 1, if x is equal to negative 1, if x is equal to negative 1, then we have 2x squared, so negative 1 squared plus x, so plus negative 1 minus 1 is equal to 0. So negative 1 squared is positive 1, so 2 times positive 1 minus 1 minus 1 is equal to 0. So this is 2 minus 1, which is equal to 0. So we have 0 equal to 0. So the left-hand side is equal to the right-hand side. Right. So that proves that our solution is correct for x is equal to negative 1. Let's check for x is equal to 1 half. If x is equal to 1 half, let's also check for that. So 2 times 1 half squared plus 1 half minus 1 is equal to 0. So this is 2 times 1 half squared is 1/4. So 1/4 plus 1 half minus 1. Let me write it again. Minus 1 is equal to 0. All right, so this is 2 divided by 4 plus 1 half minus 1 is equal to 0. So 2 divided by 4 is the same as 1 half. So we have 1 half plus 1 half minus 1 is equal to 0. And 1 half plus 1 half is 1. So we have 1 minus 1 is equal to 0. So that means 0 is equal to 0. So the same thing we have on the left-hand side is equal to the same thing we have on the right-hand side. So that proves that our solution x is equal to 1 half is also correct. Let's look at another example. So example 2. We are still solving by factoring. So example 2 is 8x squared plus 10x minus 7 is equal to 0. All right, so so A is 8, B is 10, and C is negative 7. All right, so with this, the first thing that we want to do is to find a way to express the middle term here as we want to manipulate the middle term here using the factors of the products of A and C. All right, so A times C without the negative sign. So A times C without the negative sign is 8 times 7, which is equal to what? 56. So let's list the factors of 56. 1 and 56. Factors of 56. Let me first write down factors of 56. Let me write down factors of 56. So factors of 56. Write the 56 properly. Factors of 56. We have 1 and 56, 2 and 28, 3, not 3, 4 and 14. 3 does not divide 56, so 4 and 14, and finally 7 and 8. All right, so we look at these list of factors, which of them that we can either add or subtract to get the middle term here, 10x. And we can see that 14, 4 and 14 can help us to do that. So 4 and 14 can help us to do that. So we can see that we can rewrite this equation as 8x squared. Let me write it down here. We can rewrite this equation as 8x squared. And instead of the 10x, we can write the 10x as 14x minus 4x minus 7 is equal to 0. Right, so instead of the 10x, we can write 14x minus 4x. And this equation here is the same as what we started off with. 10x is the same as 14 minus x. All right, so if we write it this way, then the next thing, the next to 8x squared plus 14x minus 4x minus 7 is equal to 0. Okay, so now we can we can get a common factor out of these first two terms, and also another common factor out of the second, out of the third and the fourth terms. All right, so if we look at the first, the parentheses, we can see that 2 is common to both 14 and 8. So we can factor 2 out. And we can see that x is also common to x and x squared. So we can factor also x out. So in the first parenthesis, we can factor 2x out. And if we do that, we will see that the remainder here, what is left of the 8x squared is 4x. Is 4x. And what is left out of the 14x is 7. And we can see that if we multiply 2x by 4x, we get 8x squared. If we multiply 2x by 7, we get 14x, right? So we can factorize the first parenthesis as this form. And for the second parenthesis, we can see that we have negative 4x and negative 7. So we can factor negative 1 out of the third and fourth term. So negative 1, and we have the remainder here is 4x plus 7 equal to 0. All right, so now we can see that 4x plus 7 is common here, is common that we can factor out. So we can factor out 4x plus 7. So if we do that, then we have a remainder of 2x here, and a remainder of 2x here, and also a remainder of negative 1 here, and this equal to 0. All right, so we can set each of these parentheses to 0. So the first one, we have 4x by the 0 product principle, 4x plus 7 is equal to 0, which means 4x is equal to negative 7. And if we divide both sides by 4, and we see that x is equal to negative 7 divided by 4. And for the second parenthesis, 2x minus 1 is equal to 0. So if we add 1 on both sides, we see that 2x is equal to 1. And if we divide both sides by 2, see that x is equal to 1/2. All right, so x is equal to -7/4, and x is equal to 1/2. All right, so these two are the solutions for our quadratic equation. So let's move on to a third example. So example 3. For example 3, um, we're still solving by factories. So example 3, we have 3 x times x minus 2 is equal to 9x² minus 7x. All right, so for this, we have to simplify and group all the variables and numbers on one side and leave 0 on the right-hand side. So 3x times x is 3x². 3x times x is 3x². And 3x times -2 is -6x. And this equals to 9x² minus 7x. All right, so let's group everything on one side. So if we subtract 3x² from 9x², we get 6x². And if we add 6x on both sides, then we have um, then we have minus 7x plus 6x, which gives us -x. So we have -x, and this equals to 0. All right. So let me rewrite this out. So it became 9x² minus 3x² minus 7x plus 6x equal to 0. So that is what resulted in this. So here we can see that x is common to x and 6x². So if we factor x out, then we have 6x here minus 1 is equal to 0. So this means x is equal to 0, and 6x minus 1 is also equal to 0. So we divide here by 6. No, first of all, let me add 1 on both sides first before I divide. So 6x minus 1 is equal to 0. So if we add 1 on both sides, we have 6x is equal to 1. And we divide both sides by 6, both sides by 6. So x is equal to 1 over 1 divided by 6. So these two are our solutions. X is equal to 0 and x is equal to 1/6. All right. So let's move on to solving quadratic equations using the square root property. So solving quadratic equations by the square root property. Solving quadratic equations by the square root property. All right, so if u squared is equal to d, where d is not equal to 0, Then we can solve for u by taking square root on both sides. So u will be equal to the plus or minus square root of d. Or you can say if we take square root on both sides, square root of u squared, and we take square root of d, the square root of u squared is u. So u is equal to plus or minus square root of d. Plus or minus square root of d simply means, this simply means u is equal to positive square root of d, and u is also equal to the negative square root of d. So this is going to be the approach that we're going to use to solve examples that involve quadratic equations and using the square root property approach. So let's use an example to kind of explain this further. So example 4, this would be example 4. So example 4, we have um, so we are solving by the square root property, and we have 5x squared plus 45 is equal to 0. All right, so if you subtract 45 from both sides, then we'll have 5x squared is equal to negative 45. All right, and let's divide both sides by 5. If we divide both sides by 5, then we have x squared is equal to negative 45 divided by 5 is negative 9. Negative 9. And so from here, if we take square root on both sides, so square root of x squared, and if we take a square root of 9, it's going to be the positive and negative of the square root of 9. So we have x, square root of x squared is x. So x is equal to plus or minus square root of negative 9. And the square root of negative 9 from complex numbers, we know that this is plus or minus square root of 9 times the square root of negative 1, right? So x, um, so x is equal to plus or minus square root of 9 is 3, and square root of negative 1 is I. All right, so we see that x is equal to positive 3i, and x is also equal to negative 3i. All right, so this is how we use the square root property. Let's look at another example again using the square root property. So this would be example 5. All right, so 2x squared is equal to 18. All right, so let's divide both sides by 2. So we have x squared is equal to 9. And let's take square root of both sides. And we take a square root of here. And that will be the positive and the negative of square root of 9. So x squared, square root of x squared is x. So x is equal to plus or minus square root of 9, which means x is equal to plus or minus 3. So x is equal to positive 3, and x is equal to negative 3. All right, so this would be the other example using the square root property. Let's look at one more example using the square root property. So this should be example. This should be example 6. Okay, so example 6, we have um, 2x plus 7 squared is equal to 40. All right, so we have this 2 times x plus 7 squared is equal to 40. All right, so the first thing that we do, we see a 2 in front of the x plus 7 squared, so we divide both sides by 2. And so that gives us x plus 7 squared is equal to 20. And x plus 7 squared is equal to 20. And from here, if we take square root on both sides, then we have x plus 7 is equal to plus or minus square root of 20, right? Square root of x plus 7 squared is x plus 7. All right, so this is equal to plus or minus square root of 20 is the same thing as square root of 4 times 5. And this is equal to plus or minus square root of 4 times the square root of 5. Right, and so this becomes x plus 7 is equal to the plus or minus square root of 4 is 2. So 2 square root of 5. So this means if we subtract 7 on both sides, then we have x is equal to negative 7 plus or minus 2 square root of 5. So this means x is equal to negative 7 plus 2 root 5, and x is equal to negative 7 minus 2 root 5. All right, so this is how we use a square root property to solve this. All right, so let's move on to completing the squares. So completing the squares, let's move on to completing the squares. Solving quadratic equations by completing the square. All right, so if we have a binomial or a quadratic expression like if we have if x squared plus bx is a binomial, then if we add then adding b, the b10 divided by 2 squared results in a perfect trinomial. The perfect trinomial. Thus, if you have x squared plus bx, and you add b divided by 2 squared, so that's if you have x squared plus bx, and we add b divided by 2 squared to 8. This becomes a perfect trinomial, which we write as x plus b divided by 2 squared. All right, so let's use an example to illustrate what we mean by this. All right, so example, this would be our 7th example. So example 7. Solve by completing the square. So we solve by completing the square. Solve by completing the square of this equation, x squared plus 4x minus 1 is equal to 0. All right, so the first term is we have to get a binomial on the left hand side. So that means we have to add 1 on both sides. So we have x squared, plus 4x is equal to 1. All right, so our b From comparing this to the standard form of the quadratic equation, our b is the number in front of the x. So b is equal to 4, right? So b divided by 2 is 4 divided by 2, which is 2. So b divided by 2 squared is 4 divided by 2 squared, which is equal to 2 squared, which is 4. All right, so we'll be adding 4 on both sides in order to write this binomial as a perfect trinomial. All right, so we have x squared plus 4x plus b divided by 2 squared, which is 4. So we add 4 here, and this is equal to 1 plus 4. So if you look at this first equation here, we are adding 4 on both sides. And the 4 is coming from adding b divided by 2 on both sides. So we have plus 4 here and plus 4 here. So we add 4 on both sides. So from this, we can rewrite this as a perfect trinomial as x plus b divided by 2 all squared. And so x plus b divided by 2 is 2. So x plus 2 squared is equal to 1 plus 4, which is 5. Right, so we are rewriting this as a perfect trinomial. And this is, if you go back to the uh, previous example, the guiding factor was if we add b divided by 2 squared, then this becomes a perfect trinomial x plus b divided by 2 and all squared. All right, so b divided by 2 is 4 divided by 2, right? So that is 2. So that means we can write x squared plus 4x plus 4 as a perfect trinomial, x plus 2 squared. And if we expand this, we'll see that we'll get back this. If we multiply x plus 2 by x plus 2, we will see that we have x squared plus 2x plus 2x plus 4. So x squared plus 4x plus 4. So we can rewrite this as a perfect trinomial of this form. All right, so once we write it as this form, then we can go ahead to use the square root property to complete it. So we have x plus 2 squared is equal to 5. And so by the square root property, we have x, we take the square root on both sides, x plus 2 is equal to plus or minus square root of 5. And so if we subtract 2 on both sides, then we have x is equal to 2, negative 2 um, um, x is equal to x plus 2 is equal to 5. So if we subtract 2 on both sides, then we have, if we subtract 2 on both sides, then we have negative 2 uh, plus or minus square root of 5. So that means x is equal to negative 2 plus square root of 5, and x is equal to negative 2 minus square root of 5. All right, so this will be our solution. Let's look at another example of completing the square. So this will be our example 8. And that we have x squared minus 4x minus 23 is equal to 0. Okay, so the first thing is we add 23 on both sides. So we have x squared minus 4x is equal to 23. And from here, we can find our b. So our b is -4, right? Our b is -4. And our b divided by 2 is -4 divided by 2, which is -2. All right. All right. So adding b divided by 2 squared on both sides would be x squared minus 4x plus b divided by 2 squared. So -2 squared is equal to 23 plus -2 squared. We add -2 squared over on both sides. So this becomes x squared minus 4x plus 4 is equal to 23 plus 4. All right, and we can write this as a perfect trinomial as x plus b divided by 2 all squared, and b divided by 2 is -1. So x minus 2 squared, and this is equal to 27. All right. So we can write this as a perfect trinomial this way. X minus 2 squared is equal to 27. So let's use the square root property on both sides. So that will give us x minus 2 is plus or minus square root of 27, right? And so this is equal to plus or minus square root of 27 is square root of 9 times 3. 9 times 3 is 27. So this becomes plus or minus square root of 9 times the square root of 3. So we have x minus 2 is equal to plus or minus square root of 9 is 3. So we get 3 and so we get plus the plus or minus square root of 9 is 3 and times the square root of 3. So if we add 2 on both sides, then we see that x is equal to 2 plus or minus 3 square root of 3. And so this means x is equal to 2 plus 3 square root of 3, and x is equal to 2 minus the square root of 3. All right, so this becomes our solution. Solving this quadratic equation by completing the square. Okay, so then let's solve by the quadratic formula. Let's look at solving quadratic equations by the quadratic formula. Solving the quadratic equation using the quadratic formula. All right, so the quadratic formula is x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. So this is the quadratic formula. Is given by the square root of b squared minus 4ac. This time b squared minus 4ac. We also call it the discriminants. All right, so let's try to use an example to explain this. So example 9. This example now, this should be a ninth example. Solve by using the quadratic formula 2x squared plus 2x minus 1 is equal to 0. So A is equal to, we compare this to the standard form, A is equal to 2, B is also equal to 2, and our C is equal to -1. So we plug this into the formula. So we have x is equal to -2 plus or minus square root of b squared. So 2 squared minus 4ac. So 4 times a, which is 2, and c, which is -1, all divided by 2a. So 2 times a, so 2 times 2a is 2. All right, so this gives us um, this gives us -2 plus or minus square root of 2 squared is 4, and -4 times -2 times -1 gives us +8. So this is 4 plus 8 divided by 2 times 2, which is 4. So x is equal to -2 plus or minus square root of 12 divided by 4. All right. And the square root of 12 can be written as 4. Let's continue on the next page. So x is equal to plus or minus, x is equal to -2 plus or minus square root of 12 divided by 4. All right. And square root of 12 is the same as square root of 12 is the same as square root of 4 times 3. So it's equal to square root of 4 times the square root of 3. Square root of 4 is 2. So it's equal to 2 square root of 3. So this becomes x is equal to -2 plus or minus 2 square root of 3, all divided by 4. And we can see that we can factor 2 out of the numerator. So this becomes 2 times -1 plus or minus square root of 3 divided by 4. All right. And so 2 divides 4 2 times. So x is equal to -1 plus or minus square root of 3 divided by 2, which means x is equal to -1 plus square root of 3 divided by 2, and x is equal to -1 minus square root of 3 divided by 2. All right, so this is how we use a quadratic formula to solve a quadratic equation. All right, so the next thing that we will discuss is the discriminant. I already mentioned it in the formula, but let's look at it again, the discriminants. So when we talk about the discriminants, in the quadratic formula, the term b squared minus 4ac is what we call the discriminant. And the discriminant determines the number and the type of solutions. If we are using a quadratic formula to solve a quadratic equation, the number of solutions that we have and the type of solution that we have is all contingent on the value of the discriminant. For example, if b squared minus 4ac is positive. Then you will have two unequal real solutions. That means our solution to x will be two real numbers which are not the same or which are unequal if the discriminant b squared minus 4ac is equal to 0. Then we have one solution, or you can also say repeated solution. Which is you have the solution as x is equal to the same number twice. And the next thing, if b squared minus 4ac is less than 0, then it's less than 0 or negative. If we have a negative number under the square root sign, then we have imaginary solutions. Then there are two imaginary solutions. There are two imaginary or complex solutions. All right, so for example, example 10, for example, compute the discriminant and determine the type of solution. So it says compute the discriminant and determine the number and type of solutions. Type of solutions of this quadratic equation here, 2x squared minus 7x minus 4 is equal to 0. So b squared minus 4ac is equal to, so our b is 7. So our b is negative 7. So negative 7 squared minus 4 times a. Our a is 2. And our c is negative 4. So this becomes 49. And negative 4 times 2 is negative 8 times negative 4 is positive 32. And this equals to 81. And since 81 is positive, we can say that there are two real and unequal solutions. 81 is positive. So we have two real and unequal solutions. Unequal solutions. All right. Two real rational solutions. All right. So the next thing that we want to look at is let's look at some application problems using the quadratic formula. Let's look at some application problems using the quadratic formula. Let's see. We want to look at a few examples of an application problem where we use the quadratic formula, and we will see that we know that the quadratic equation is a very common technique that is used to solve a lot of problems all around us. So we want to see how, if we have an application problem that involves a quadratic equation, how we can solve that application problem. When it involves a quadratic equation, we want to see how best to solve such kind of problem. So we will look at a few of such problems, and from those we will be able to determine if we see other additional quadratic equations, whether we can solve them. All right. So our next example is so we are looking at some application problems. And this is example 11. Okay, so in example 11, we are given the formula. We are given the formula P is equal to 0.01 a squared plus 0.05 a plus 107, right? And we are told this models a woman's normal systolic blood pressure, models a woman's normal systolic blood pressure. Blood pressure P. So this models a woman's normal systolic blood pressure P at age A. And so we have to use this formula to find the age to the nearest year of the woman whose systolic blood pressure is 105. So we have to use this formula. Use this formula. This formula to find the age. Use this formula to find the age to the nearest. Find the age to the nearest year of a woman whose normal systolic blood pressure whose normal systolic blood pressure is 115 milligrams Hg. All right, so we are told that P represents the woman's systolic blood pressure and A is the age. So we want to find A, and we are given P. So P is 115. So we can write this as 115 is equal to 0.01 A squared plus 0.05 A. All right, so this becomes our quadratic equation, and we can write this in standard form as we can write this in I think I missed 115 is equal to 0.05 A plus 107 plus 107. All right, so we can write this in standard form by subtracting 115 on both sides. So we have 0.01 A squared plus 0.05 A plus 107 minus 115. And this will be equal to 0. So we have 0.01 a squared plus 0.05 a minus 8 is equal to 0. All right, so we can use the quadratic formula to solve this. We know that the quadratic formula x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. The quadratic formula works all the time. So if you have a problem and you don't know how to use the factorization approach to solve it, the quadratic formula can straight away give you the answer. So here we know that a is equal to 0.01, b is equal to 0.05, and c is equal to -8. So let's substitute this into the formula, and we will have a is equal to minus 0.05 plus or minus square root of b squared, so 0.05 squared minus 4 times 0.01 times -8 divided by 2 times 0.01, and this equals to -0.05 plus or minus square root of 0.05 squared is 0.0025, and this plus 4 times 0.1 times -8 is 0.32. All this divided by 0.02. All right, so we have a is equal to 0.05 plus or minus square root of 0.3225 divided by 0.02, and this gives us negative 0.05 plus or minus 0.568, 0.568 divided by 0.02. Okay, and from here we have a is approximately equal to negative 0.05 minus 0.568 divided by 0.02, which is approximately equal to negative 30.9, and a is approximately equal to negative 0.05 plus 0.568 divided by 0.02, and this is approximately equal to 25.9. Right. The blood pressure of a human being cannot be a negative number, right? So negative number is not part of the solution. So a is approximately equal to 25.9. Will be our solution. The age of 25.9 will be our solution. So nearly 26 years. So the individual is nearly 26 years. Will be our solution. All right, so the last thing we want to discuss under um, quadratic equations is the Pythagorean theorem. The Pythagorean theorem. Is the Pythagorean theorem. So the Pythagorean theorem is given by if we have a right angle triangle. Right angle triangle is a triangle that has 90 degrees on one side. So we have this side as A, this side as B, and this side as C. And we call this side small c, this side small b, and this side small a. These are the legs, and this is also the leg of the triangle, and this is the hypotenuse. All right, so if we have such a relationship, the Pythagorean theorem states that c squared, the side c, is equal to the length of the side a squared plus the length of the other side b squared. So with this, we can use the Pythagorean theorem also to solve some application problems, or in general find um, the other side of a triangle. For example, if we have let's use the Pythagorean theorem in one example. So this would be example 12. And example 12 says that a rectangular park is 4 miles long and 2 miles wide. How long is a pedestrian? How long is a pedestrian route that runs diagonally across the park? All right, so we have a park that is rectangular in shape, is 4 miles wide and 2 miles deep. 4 miles long and 2 miles wide. And we want to find the length of a pedestrian route that runs diagonally to the park. So with this, we can see that we can use the Pythagorean theorem to solve this. So the Pythagorean theorem is, let's say this side we don't know, so let's represent it by c. So by the Pythagorean theorem, we know that c squared is equal to a squared plus b squared. So c squared is equal to a, which is 4 squared plus our b, which is 2, so 2 squared. So our c squared is equal to 4 squared is 16 plus 2 squared, which is 4. So our c squared is equal to 20. All right, so our c is equal to the square root of 20, right? And the square root of 20 is um, square root of 4 times the square root of 5. So the square root of 20 is 2 root 5. So C is 2 root 5 miles. So the length of the diagonal is 2 times the square root of 5 miles. All right, so this brings us to the end of section 1.5, where we discussed quadratic equations. And so we will end here, and we will see the next one, which is 1.6. Bye-bye.